What's up, ninjas? Welcome back to part 2 of day 2 of 7 days of Injective, where we'll be covering smart contracts. So here are all the things that we'll cover in day 2, and we have already done the first 3. Now in this video, we'll be focusing on deployment, verification, and interaction with the smart contract that we have already compiled and tested. So the first thing is to deploy EVM bytecode to the blockchain, right? So the tests have already passed and now it's time to ship it. In order to do that, we are going to run our deployment script. So we do npx hard hat run, and then we invoke the deployment script, which is this script, and then we specify the network as INJ testnet, which is defined over here inside of hardhat.config, right? So you can see here, INJ testnet has specifies the testnet RPC URL and chain ID, and then the private key, it gets it from the .env file, which we've set up earlier on. So this will allow it to pay for the transaction because that account with that private key has been funded previously using the testnet faucet. Now, back to the deployment script. Over here, you can see we've got ethers, or I should say a hard hat version of ethers that has been augmented to have this get contract factory to read from this compiler output, right? So we've got the ABI and we've got the bytecode. So the deploy, that gets stored in counter with a capital C. And then the instance of the counter with the lowercase c is created using a deployment transaction like that. And then once we have the deployment transaction, we wait for the transaction to be validated and added to the blockchain. And then finally, we get the address and print it. So that's what it does. I'll run that command. And there we go. The smart contract has been deployed to this address, right? And the deployment script has executed successfully. So what we'll want to do right now is to open up the Explorer, the block Explorer, and in the search bar, paste the address, and there we go. Right, so we'll see a smart contract over here. And you'll see in this smart contract that we only have the bytecode, right? We do not have the ABI or the source code. So even though this code is immutable, it is not understandable, and therefore, despite its immutability, it is hard to trust, right? It is effectively a black box, right? So we know the contract exists, but we don't really know what it does yet. Now the next step is to verify details on the Network Explorer. So we're going to open up that black box, and to do so, we'll verify the smart contract using the Explorer, right? To do so, we'll run the verification command, right? So I'm going to set smart contract address, and then I'm going to paste this just so that we store it over there, like so. Smart contract address, and then I'm going to do npm hardhat verify, specify the network flag for INJ testnet, and then put the smart contract address there. So now it's going to verify the smart contract. All right, it's submitted and it has verified. So take a look at this. This is what the smart contract page looks like at the moment, right, in the contract tab. Now, if I refresh this page, now we'll see something different, right? So we see a check mark next to the word contract in the contract tab. And we also see that it has code and read-write buttons. We'll see this thing saying contract source code is verified. And we also see, in addition to the bytecode that was there previously, we also have the compiler settings, the source code that was submitted, and we also have an ABI. With the code over here, we're able to be confident that we know what the smart contract is doing, not just that it's immutable. And with the ABI, we know how to interact with it. And in fact, what we can do is we can click on this read-write contract and use this page as a DApp, right? So if I press the read value, right, it'll get me the current value of the value property, right, which is 0. But let's actually do that programmatically as well, right? But before we go to that, let's actually talk about what we did with deployment and verification. So let's distinguish between the two different things that we just did. Deployment is an on-chain transaction where we sent a transaction containing a bytecode. The blockchain network executed it, and that did a couple of things, right? It copied the bytecode into permanent blockchain storage at a specific address, and that address is the smart contract address. The next thing it did was it ran the constructor function to set up the initial state of the blockchain, right? Now, verification, on the other hand, is a completely off-chain action. There was no transaction that was sent to the blockchain itself. We simply talked to the Explorer's API and we said, here is the source code, here is the compiler settings, and the Explorer, the Block Explorer, independently ran the compiler using those settings and the source code on its own server, and then it got the compiled output from that. And it compared that compiled output to the one that we submitted, and said, okay, these two things, they're matching, right? They are the same. So then it says, okay, that's verified, and it'll then display the source code and the API as we saw just earlier on. Now, if it wasn't a match, then it would just be rejected, and it would just not show the verification status. It will not show the source code and so on, right? But now that it has, we're more confident in the smart contract actually being doing what it claims to have done. Now, remember that the deployment changes the state of the blockchain and therefore uses a transaction, whereas in verification, it doesn't need to change anything on the blockchain. And so the only thing that really changes is what is displayed on the Block Explorer, and that is off-chain. Now that the smart contract has been deployed and verified, it is live and it's time to talk to it. We'll start by querying the smart contract, and this means reading blockchain state. To do so, we'll enter the interactive console, and to do so, we'll use this command, npx hardhat console, and then the network flag as before is inj testnet. So now we're inside a read evaluate print loop, i.e. a shell, but this shell isn't ZSH as it was before, but rather Node.js. And so you can type any JavaScript that you want into it, but it also has been augmented by Hardhat to insert some convenience functions, such as the wrapped versions of Ether that we had access to previously. So first up, I'm going to set the smart contract address to match this one that I've deployed. All right. And then I'm going to create a smart contract factory for counter. And this is exactly the same as what is in the deployment script. Then this one is to create an instance of the smart contract, but rather than deploy a new one, as in the deployment script where we did counter.deploy, now we're doing counter.attach. So now we have a counter instance that will talk to the already deployed smart contract. All right. Now we're ready to perform our query. So we're going to do await counter.value. And that sends a JSON RPC request talking to the smart contract, and you get the value back of 0. Now we can look at the value inside of here and press the read button, and we get a value of 0. So it matches. Note that the end is just a suffix to denote big integer. So it's just saying it's not a regular integer, it's a big integer because in Solidity, the numbers are really big for uint 256. Okay, so that's your query done. Now, the next thing we can do is to update the smart contract. So we'll continue in the same interactive console, but we're going to invoke a function, and this function updates the state of the smart contract, right? So that means that we need a transaction. All right, let's do that. So previously, we were looking at value, right, which is just a getter function. It didn't even have a function written here, but this increment function actually does something. It changes the state within the smart contract. All right, so to do that, what we're going to do is get transaction response, set paste, All right. So transaction response is equal to await counter.increment, and we pass in a parameter of 1. And then we set in some gas price and gas limit values for the config for the transaction. Then we get transaction hash, right? Now let's copy this and we will paste the transaction hash into here, and we can see exactly how it has transacted. So we can see that the transaction has succeeded. That means it was accepted by the blockchain and added to the state. And we can see here, if we press a few details, what exactly happened. So this is the raw transaction, right, which is not human readable, but that's what the EVM sees. And since the smart contract has been verified, it has access, the Block Explorer has access to the API. We can decode this using the API and find out that this was actually the increment function, and it was sent in a parameter of 1. And yeah, that's exactly what we did, right? We sent in a parameter of 1 to the increment function. All right, now let's repeat the command from earlier on, right, to query. So await counter.value again, and this time we'll get a value of 1, because 0 plus 1 is equal to 1. Now, let's say I repeat the transaction yet again, but instead of incrementing it by 1, I increment it by 100. So from 1, it should be 1 plus 100 is equal to 101, right? Let's get rid of the const. We're not going to use it anymore. All right, so just increment by 100, and then let's do a counter.value again, and we get a 101, right? And let's actually take a look at the smart contract again. Go to the read-write contract, and if we press value again, then we'll see 101, and it corresponds because they're both reading from the same smart contract state. All right. So now we've completed both querying and updating the smart contract state. All right, let's talk about read versus write operations. The difference can be thought of as when we think about a blockchain as a state machine. So the blockchain stores its current state. For example, who owns what and what values are stored in a smart contract. All that is state. All right. And the difference between queries and transactions comes down to what happens to the state. For queries, these are read operations. They only look at the current state. They don't actually change the state. So that means that they are free to do, and they're also pretty fast. Now, transactions, on the other hand, they are write operations. These are actually instructions to transition from a before state to an after state. And because of that, you're doing something on the blockchain. That means that you need to sign your transaction. This instruction to change the state is a transaction, and you need to sign it by using your account. And of course, you also need to pay for the additional storage, the processing, etc. So that's what goes into the transaction. And of course, because of that, the transactions aren't free. You actually pay for them, and they're not almost instant, right? You actually have to wait for them to confirm. Now, in the case of Injective, pretty fast blockchain, you probably won't even notice the difference. But in other blockchains, you can be waiting for seconds, sometimes minutes, before the transaction gets accepted into blockchain. Okay, so understand this distinction between read and write operations, or queries versus transactions, is fundamental when you want to understand how blockchains work, or how the EVM works, and therefore how to develop smart contracts. So we have just covered all the theory plus demos for day 2 on smart contracts, and we split it over 2 videos. So if you haven't gone through the steps in those 2 videos for today yourself yet, please be sure to do so now. And you have a couple of options to do so. They'll only take a couple of minutes to complete as well, right? Once again, those options are to rewatch this video and the previous one from the beginning, or to follow the instructions in the linked tutorial, link provided below. In the next video, we'll have a short quiz with a few multiple choice questions. So watch that to self-assess your understanding of this topic. Thanks for watching, and see you in the next video. But before you go, Note that this is a preview edition of the video that is part of the 7 days of Injective course. We are creating the full version of this course with all of the bells and whistles. And if you watch this far, I'm sure that you will be keen on that too. So do sign up using the form by scanning the QR code or clicking on a link in the description of this video. For now, on to the next video.